this video, we're talking about functional notation. Remember that we call an equation a function when there's only one value that we can get back for the dependent variable for every value that we plug in for the independent variable. In other words, in the past, we've dealt with equations like y equals x plus 2, for example. And we usually call x the independent variable and y the dependent variable. And the reason that we name them this way is because we usually plug in values for x, and then the values that we get back for y depend on whatever value we plugged in for x. So for example, if I plugged in 1 for x, I'm going to get y is equal to 1 plus 2, and then I'm going to get y equals 3. So I see that the point 1, 3, where x is 1 and y is 3, is a solution to this equation, and the value 3 depended on the value 1 that I plugged in. So I plugged in 1 and I got 3. So the value I get for y depends on whatever value I plug in for x. Sometimes you're going to see equations like this one, where instead of having y, we'll have something like f of x is equal to x plus 2. So this is the same equation, except we've replaced the y with f of x. This is read f of x. And when you see notation like this, it means that this equation is a special type of equation that we call a function. And a function is an equation where there's always only one possible output value of f of x for every input value of x. So in other words, if you can plug in one value for x that gives you multiple values for y, or multiple values back for f of x in this case, then the equation is not a function. An equation is only a function when every value of x gives back only one value of f of x. So for example, we know that the equation y equals the square root of x is not a function, because if we plug in 4 for x, we get y equals the square root of 4, and we know that the square root of 4 could be positive or negative 2. In other words, we have two solutions to this equation when we have x equals 4. We have 4 positive 2, and we have 4 negative 2. Because this value of 4 here can result in two different values for y, one could be positive 2 and the other could be negative 2, this equation is not a function. Every value you plug in for x has to result in only one unique value for y. If that's the case, then we can call the equation a function. And if the equation is a function, then we like to write it with functional notation, which is this f of x notation here, instead of just y. So instead of just y, we write it with something like f of x, and this means the function f in terms of x. We could also have a g function like this, g of x equals, let's say, x minus 4. This would be the function g in terms of x, or g of x. So when we go up here and look at our examples are telling us find p of negative 3 when we have p of x is equal to x squared minus 3x. So looking at this, we know that this is a function of p in terms of x. We know it's a function because we have this special notation p of x instead of just y equals x squared minus 3 of x. So this tells us that every value we plug in for x is going to give us back only one value for p of x. And they're asking us specifically to find the value we get back when we plug in negative 3 for x. So notice here that we have this notation here, p of x, and we have x inside the parentheses. Well, if we match that up here, we have p of negative 3. When we look at this negative 3 value inside the parentheses, and we have this x value inside the parentheses, this is just telling us plug negative 3 in for x. So the way that we solve this is we say p of negative 3, the value we're trying to find, is equal to, and now on the right hand side we plug negative 3 in everywhere that we have an x. So we get negative 3 squared minus 3 times negative 3, and then we just simplify. So p of negative 3 is going to be equal to negative 3 times negative 3 is positive 9, minus 3 times a negative 3 is a negative 9. These negative signs are going to cancel and become a positive, so I'm going to say p of negative 3 is equal to 18. And I can say then that the point negative 3, 18 is a solution to this functional equation. Now here's another example. I want to find h of 4 when I have the function h of x equals 4x minus 3. So again, I'm just going to plug 4 in for x, and I'm going to say h of 4 is going to be equal to whatever I get when I plug in 4. H of 4 is going to be equal to 16 minus 3, or h of 4 is going to be equal to 13. So 4, 13 is a solution in this function.